start by sketching out FA and FB, and we were provided with a coordinate system x right, y up. Magnitude of FB is 800 newtons, directed 30 degrees below the x-axis. And FA, they want us to find theta specifically as measured from the y-axis, so they do indicate that. And they want us to find the magnitude of FA. And this is going to be equal to, when we apply these two things simultaneously, that's the same as applying a single force only in the x direction with a value of 1250 newtons. So these two things happening are equal to this one thing happening. That's my R. And it's still going to be true that R is FA plus FB. The resultant is still the summation of FA and FB. Questions on the premise of what we're going to be looking for here? So what's the first step that we can take to start to solve this? Again, what are we ultimately looking for? Magnitude FA and theta is indicated from the diagram.
You can split the 800 into x and y components.
Right, to do this operation, we want to be in component form. Right now, we don't have anything in component form. So we can start by FB is the easiest place to start here. According to our coordinate system, it's in quadrant number 4, which means the x component should be positive, the y component should be negative. I component is going to be 800 cosine 30, since the adjacent is going to lie parallel to the x-axis. And the y component, we're going to use sine, and again, that's in the negative y direction that it's pointing, is going to be 800 sine 30. Putting it into decimal form, FB we're going to find is 693I minus 400J. And we're in newtons for this. Right, so we have I, we have J components for FB. Now we can do the same thing for FA. There's actually two different ways we can do this. One is algebraically going to be a little bit easier. What is the I component of FA going to be?
1250 minus 892.
Well, taking a step back, before we do that step, how can we express this just from the diagram for the components of FA? We have a magnitude, we have some indication of the direction. It's just we don't know them as numbers right now. Yeah. Right, we could write this as its magnitude FA times the sine of theta, I hat, plus the magnitude of FA times the cosine of theta, J hat. Again, these things we don't know, but we do know FA is the magnitude times the sine of theta will give us how much of that hypotenuse is horizontal, how much is vertical. And we could write it this way, but I'll say that having an unknown, we don't know theta right now, having an unknown stuck inside of a trig function makes it much more difficult to solve by hand. So even though this is correct, I'm going to express it in a different way that's going to make it algebraically easier to solve. So instead of doing it that way, I'm going to say I can break FA into a horizontal and vertical component that I can call FAX and FAY. I don't know what they are right now, but I'll be able to find them. I still have two unknowns, but now I don't know the coefficient in front of I and the coefficient in front of J. Rather than not knowing the magnitude and the direction, I'll be able to get that information, but this as an intermediary step is going to be easier to do. So eventually I need to find FAX, FAY, so I'll need two equations to find these two unknowns. So we don't know what they are, and that's okay right now, because R, we were prescribed in this. If we look at R, we can easily express R in its component form. It's pointing to the right. We're given its magnitude. So the resultant we know should be 1250I plus 0J newtons. We know this relationship is true, that R is FA plus FB. Since we're looking for things inside FA, we can rearrange this vector equation and say it's just going to be our resultant minus the vector FB. Okay, so FA is FAX in the I hat direction plus FAY in the J hat direction. So that's my left side of this equation. And my right side, I'm just going to now subtract like terms. 1250 minus the 693 is going to leave us with 557I. And the 0 minus negative 400 will leave me with a positive 400 in the J hat direction. I have a single vector equation here. I don't know FAX, I don't know FAY. So it appears as though I only have one equation for my two unknowns. But with vector equations, I can actually split it into multiple scalar equations. With a vector equation, it has to be true that the coefficients of I, J, and K have to be the same on the left-hand side as they are on the right-hand side, which means I can split this into actually two scalar equations. I can take my coefficients in front of I hat on the left and equate them to the coefficients in front of I hat on the right. Coefficients in front of J hat on the left. Coefficients of J hat on the right, 400. So notice the difference between this is a vector equation. It has i's, it has j's. But when I split it into these two scalar equations, the i's go away, the j's go away. I'm only looking at the coefficients in front of them in these two equations. Whereas here I have the coefficients and I have the directions I hat and j hat. So this actually becomes two equations for those two unknowns, the components FAX and FAY. So algebraically, this was much easier to get to than if I had said F sine theta and F cosine theta. But now I do need to find out what we're interested in. Again, we were looking for what must the magnitude of this FA be and what must specifically that angle theta be. What I have found is this leg is 557, and the vertical leg is 400. Now I can find the magnitude easily because I know how much is in the x, how much is in the y. So as we've been doing before, to find the magnitude of FA, I just take the square root of the sum of the squares of the components. So I need to pull on that rope with a magnitude of 686 newtons. That's the magnitude of this vector, which I didn't actually write yet, so I can also write it in component form. So I have the magnitude, and then finally, I want to know, as they drew it there, what that angle theta was. So looking at this diagram, theta is being measured from the positive y-axis, so I want to make sure I'm finding theta, even though oftentimes we find it from the positive x-axis, but here, to find that theta, I need to use, if I want to use tangent, say, I need the opposite over the adjacent in order to find the theta. So in this case, the opposite with respect to the theta is that 557. The adjacent with respect to the theta is the 400. Come over here so we have room. So if we make that evaluation as measured from the positive y-axis, I should get a theta value of, this is going to be 50, I believe we should get 54.3 degrees as our value for theta.